Your app works fine. Then one day, updating the login page takes down the payment system. Nobody touched payments. That's the moment architecture stops being abstract and starts being your problem. A monolith is a single application where every feature, user accounts, payments, notifications, search, lives in one code base and deploys together as one unit. A microservices architecture breaks those features into separate, independently deployable services that communicate over a network. Think of it like a restaurant. A monolith is one chef who handles everything, takes orders, cooks, plates, handles the bill. Microservices is a full kitchen brigade, a separate person for each station, each one specialized, each one replaceable without shutting down the whole kitchen. This decision shapes everything downstream: how your team works, how fast you can deploy, how your system fails, and how much infrastructure you need to manage. A startup shipping fast benefits from a monolith. One code base, one deployment, one place to look when something breaks. But as the team grows, say 12 engineers all merging into the same repo, deployments become a coordination nightmare. A bug in the notifications module blocks a release for the entire product. That's the moment teams start talking about microservices. Not because microservices are better, because the pain of staying coupled has finally exceeded the cost of splitting apart. This also shows up constantly in system design interviews. When someone asks, "How would you design Instagram?" the answer isn't technical until you've answered this question first. In a monolithic application, every module shares the same process, the same memory, and usually the same database. When you deploy, you're deploying everything. That's fast to build initially. No network calls between components, no serialization overhead, simple debugging. But the coupling is the cost. A memory leak in one module can crash the whole service. A schema migration on the users table can block work across every team touching that code base. Microservices decompose that application into autonomous services, each one owning its own data, its own deployment pipeline, its own technology stack if needed. They communicate through APIs, typically REST or gRPC, or asynchronously through a message broker like Kafka or RabbitMQ. Each service can be scaled independently. If your search service is under load but your checkout service is idle, you scale search without touching checkout. But here's where teams underestimate the complexity. Microservices are a distributed system, and distributed systems fail in ways monoliths never do. Network latency, partial failures where one service is up and another is down. Data consistency across service boundaries because there's no single transaction spanning two separate databases. You need circuit breakers to stop cascading failures. You need distributed tracing to follow a request across 5 services when something goes wrong. Tools like Kubernetes handle orchestration, meaning it manages where and how each service runs. A service mesh like Istio handles communication, security, and observability between services. And if this is the kind of thing you want to actually understand rather than just recognize, Stack Future covers one concept like this every day. The split also changes team structure. Amazon's two-pizza team rule exists because microservices work best when each service is owned end-to-end by one small team. Conway's law is real. Your system architecture will mirror your communication structure. Say you're running an e-commerce platform as a monolith. You deploy a new discount engine. Something in the new code causes a connection pool exhaustion. The app runs out of database connections, and suddenly the entire site returns 500 errors, not just discounts, everything. You roll back the entire deployment to fix one feature. Now imagine that discount logic is its own microservice. When it fails alone. Your product pages still load. Your cart still works. You can isolate the broken service, take it down, fix it, redeploy just that service, maybe in under 10 minutes, without ever touching the other services. This is what the strangler fig pattern describes. Gradually extracting functionality from a monolith into services, one piece at a time, without a full rewrite. Martin Fowler coined it. Many real migrations at scale, including parts of Netflix and Uber, followed exactly this approach. Monoliths aren't legacy, and microservices aren't automatically better. Monoliths are simpler to build, simpler to debug, and often the right call for early-stage products. Microservices buy you independent scalability and team autonomy, but they charge you in operational complexity. The question isn't which is better, it's which trade-offs match where your team actually is right now. If this helped it click, hit the like. It tells the algorithm someone learned something today.